morning, everyone. Thanks, everyone, for coming to the Elixir conference. Also, again, Jean, for organizing the third Elixir conference, the second here in the United States. And this is going to be, I'm still getting used with giving those talks. It's going to be a talk where we're going to say, hey, where Elixir is right now. You know, Elixir 1.1 just came out, and what we can expect in the short term, and what is being investigated, researched for the long term. So to get started, let's do a very quick recap, right? We had Elixir 1.0. It was released in September 2014. Actually, when we had the first Elixir conference, it was July. We didn't even have Elixir 1.0 out yet. And by that time, when Elixir 1.0 came out, we had more than 180 contributors. So thanks, everyone, for contributing. And as I said last year, is not only about code contribution, right? And Jessica said it very well yesterday. Like, everything you write, every time you organize something, you talk to our coworkers and say, hey, you know, check this out. It's a contribution. Those are a little bit harder to track, but it's definitely a contribution. And before Elixir 1.0 came out, we already had 3 books, right, from 3 major publishing companies. And we have many more today. You can go to the website. There's a learning section where you can find more of those. And we, as I said, the first Elixir conference was in July. It was before Elixir 1.0 came out. And what was really exciting about all this thing and what happened in this last 1 year is that when one of the design, well, last year I spoke about the goals behind Elixir, right? And one of those goals was extensibility, because I like to say, you know, like, computer science is such a wide field, right, that we cannot possibly tackle all the domains. So your language needs to be extensible. You need to be able to get it and extend and bring it to the domain you're working on. So we have seen a lot of folks using Elixir in anything related to the web infrastructure. Even you're doing something custom on TCP or UDP, up to a regular web application and up to distributed systems, right? We are seeing a lot of interesting use cases coming up from running Elixir in embedded systems, right? Which is quite interesting for me because it's an area that I have like zero knowledge. So I'm always fascinated, like, whoa, you got it running in that very small thing. That's fantastic. I didn't know you could do that. So those are very interesting cases coming out. I also heard those are coming out soon, I believe, of cases of Elixir being used on financial and video platforms for more heavy data processing and things going really fast over the network. They need to do something and send elsewhere. And also graphical user interfaces. And this, I have seen some people playing with it and doing interesting stuff. And it's really interesting because we have seen a lot of functional, and we heard in this conference, even if we were talking about Elm and Elms in particular, about the browser, we have seen a lot of interesting research happening regarding how we can apply functional programming when you're building user interfaces and some other ideas, right? So this is very exciting because, you know, it's spreading, right? It's not only one particular thing, and people are getting Elixir and taking to the domain they're working on. And with Elixir 1.1, it was released a week or 8 days ago, okay? And accumulated over all the time from since Elixir beginning until Elixir 1.1 came out, we had almost 300 contributors. This is fantastic. So in this period of 1 year, we got at least 100 new contributors, and also counting people that were still contributing, you know, that contributed before 1.0 and they continue till today. So that's really, really fantastic. I also started tracking the data that's coming from hacks. So we are almost hitting 1,000 packages on hacks, and we have more than 6.5 million downloads. So, you know, it's happening, right? It's nice to come here 1 year later and see, you know, we have more contributions, we have more packages, we have, you know, the conference is bigger, right? What was the number for last year, Jim? 99, right? And we had full training, so it's really exciting. what is happening, right? And so and what I want to do for this talk, since Elixir 1.1 is quite new, I want to talk a little bit about what is new with Elixir 1.1. And the reason I want to do that is, who here read the changelog for Elixir 1.1? Please raise your hands. Oh, wow, I was going to make a joke, but I cannot make the joke now. OK, so yes. So good, you read the changelog. I should continue writing that then. OK, great. So good. For those who haven't read, you should definitely check out, because we keep the changelog all tidy and organized. So Elixir is split in 6 applications, right? It's Elixir itself, interactive Elixir, which is the repo, XUnit, the test framework, Mix, the build tool, and the logger system, and the EX, which is the template engine. So we split everything by the categories, if it's an enhancement and bug fix. So we hope you can read that and have an idea of what is new with Elixir 1.1. And I'm going to do a very quick recap of what we can see. So being a functional programming language, what we expect with Elixir 1.1 is to have more functions, right? And this is almost all the functions that came with Elixir 1.1. They are being added to the new modules. I took like 2 out because their name were too big, so it messed up my formatting, so they're not there. But I'm not going to go over all those because, So I just want to give a quick overview about some interesting things. So Enum, that we use a lot, we already have a bunch of convenience functions for working with collections in Enum. We got a couple more. Here are some of those. So we have Enum unique that guarantees that all the items in the collection are unique. But we have the dupe now, for example, that only guarantees that if the item is repeated, right, it's going to emit just one of those. And many of the functions we added here, they were also added to the string module, right, which is kind of the lazy counterpart of Enum. So now I can finally get a random entry from a collection or a number of random entries, and a bunch more happening to Enum. With string had some nice additions, but the coolest of them all is the gerund distance that can calculate the distance between 2 strings. And we are using this, for example, in mix. If you want to say like mix help, and then you do a typo and you say mix hello, it's going to say, hey, this task does not exist. Maybe you meant help instead. So we are going to use it more and more for providing like, did you mean features? Like, hey, maybe you meant that. And we use the gyro distance to calculate the distance between strings and kind of have an idea which one was the user possibly meant. The task module also got some nice improvements. So the task module is used in Elixir. We use it to spawn processes, but it also has the async await pattern, right? And this code here works with Elixir 1.0, right? So what you can do is that if you want to spawn a process, right, to calculate something and read the result later on, you can use async await. And this is important, right? If you're using async, you need to use await because we are expecting, that you want to read the result back. And the reason why it's important is because we link the 2 processes. Because if you're spawning a process just to calculate something, if the parent process dies, right, nobody's going to read the result. Okay, so we cancel the computation. So it's important that every time you're using async, use await. But await was kind of binary, right? It's like, or every time you call await, you give the task and you give a timeout. The timeout is important as a back pressure mechanism, right? If things are not finishing in the time expected, it's because the system may be clogged up or responsive. And await is going or give you the result or fail with timeout. And fail is like, it's going to exit the process. And this is what we want most of the times. But sometimes, and this is what we have with Elixir 1.1, is that we want to say, hey, actually, I just want to know if the task finished. And I'm going to give it 5 seconds, right? So task yield is for that. I can say, hey, did the task finish? I'm going to wait. I can wait 0 seconds, or I can wait 5 seconds. And then it's going to return the result, or it's going to return nil. And then from that, I can call yield again, right, and wait more 5 seconds. Or eventually, I can just shut down. And shutdown expects a timeout, or brutal kill, which says, hey, I'm fed up with you. I'm not waiting anymore. Just, brutal kill. And so brutal kill is not something new. We're not like being very mean. It comes from OTP. And it's what we use when you say, you can use queue and then you say, hey, I'm kind of waiting for my brutal queue. Like, I'm shutting you down, not waiting for anything, not giving you a chance to clean up or anything. And we use it exactly in the situations where we already waited for some time, and then the only option is to, shut down and queue and not have the thing and not waiting. Okay, so those are very small additions, and that's mostly, Elixir now, the compiler is a little bit faster. We are emitting more warnings to help you find like code that's never going to execute or code that's possibly wrong. But that's generally what happened with the Elixir. But as I said, we have a bunch of other applications with Elixir, and two of them got a bunch of nice improvements, and I want to talk very quickly about them. So the first one is XUnit. So XUnit 1.1 has a feature called capture log. So this code snip I'm showing here, it already works with Elixir 1.0 because for example, if you're testing some code or if you want to test some code that's doing I/O, you can import the capture I/O function and pass the I/O that's happening inside that function and capture it or silence it because you don't want things being printed to your terminal, for example, while you run your tests, right? And that works for a while. But before Elixir 1.0, we added the logger system, which means that developers, they are correctly not doing I/O to print stuff, but they're using the logger system. But we don't have easy way to shut down the logger system during tests. And that's exactly what capture log is going to do with Elixir 1.1. It's very similar to capture I/O. You just import capture log. And now you can say capture log, and all the log that happens inside that function is going to be captured. And what is really nice about capture log is that we can also use tags to say, hey, I want to capture the log for this particular test. Or you can configure it for the whole test suite and say, hey, I don't want anything to be logged to my terminal while I'm running my tests. And the nicest thing of this all is that imagine that you're using capture log, and then your test fails. And the reason is in the log, right? But you capture it. You just discard it away. So what we do is that if you're using capture log, using any of those two ways, and the test fails, after we print the reason why the test failed, we are going to say, hey, and by the way, this was what was being logged while the test ran. So now you have all the information in one place. You don't need to go after your logs to find everything out. So I think this is a really nice addition to Elixir, especially considering that almost every project I worked on, I had to implement a very half-assed capture log. So now we have it properly implemented and properly integrated with XUnit. So that's really nice. We also added not implemented tests. So now if you want to say, hey, I just want to kind of spec out how your system should work, you can just type the test, leave out the do end block. And what's really nice about this is that tests that are not implemented, they are automatically tagged as not implemented, which means you can run the test, say, hey, I want to run only the not implemented ones, so you can focus on those. Or you can, if you want to check that everything works outside of the not implemented ones, you can exclude them and so on. And a bunch of other improvements. So stack trace depth is now configurable and has been increased to 20. So because of recursion, the virtual machine keeps by default only the 10 latest items in the stack trace. And tail recursion and last call optimization already ends up removing a lot of items of the stack trace. So what would happen that even if you have the limit of 10, sometimes you would run the test and then things would be left off. And you say I can't see what triggered the error, right? So we increase the stack trace depth to 20. And if you want to increase it even more, it's possible now because it's configurable. We have improved a lot of the assertion macros. So we give even more information to help you find out what is wrong and how to fix it. We also added the ability to skip tests. And oh, this is a nice one. And the proper line numbers in doc test failures. So Elixir has this feature called doc test, right, where you can write the documentation and put the tests in your documentation and write code in your documentation, right? Say, this is how it should work, and we are going to test those code snips in the documentation. But if you're using that, and you should, what would happen is that if the test in the documentation failed, we would point to the first line of the documentation, which was horrible. So now we are pointing exactly where the error happened, and it's a very nice improvement. So yeah, so that's it for XUnit. And Mix is the other one I want to talk about. Got some really nice improvements. So the first one is a test called profile.fprof. So if you have a script and you want to kind of profile your application, you can just write down a script that's calling your APIs, and it's going to print what were the functions that were being called, how many times they were called, how much time it was spent, and so on. And that's already a very nice addition, and we have a bunch more happening in Mix. So the first of them is that the Mix compile task, which is what we use to compile our code, now tracks only compile time dependencies for Elixir. And what this means is much faster compilation times, okay? So what happened with Elixir 1.0 is that when we compile your code, we generate a graph of the dependencies in your code. Right? So say, this module calls this one, calls this one. So if you change this, we kind of have to force everyone up, right, to recompile. But what we were doing is that we were tracking both compile time and runtime dependencies in the same way. So you can be calling a module only at runtime, and it would force the recompilation of everything, and that's unnecessary. Wait. Okay. Yes. So we would track the compile time and the runtime dependencies together. So what we're doing with Elixir 1.1 is that we now know if something's a compile time dependency or a runtime dependency, and we only recompile the compile time ones, which are the minimal dependencies we have in your code. Most of them, like you're calling some function inside of your functions, right? You're not calling a lot of stuff on your module body, which is the compile time stuff. So if you go, especially, and this is especially important, for example, in things like Phoenix, because you have a router that kind of links to your whole application, right? So you would change something that would trigger the router that would kind of like force your whole application to recompile. So Elixir 1.1 is going to be much better in this aspect. Something that has been asked a lot, and we now have we have a recompile function inside IEX that is going to recompile our Mix project. So if you have IEX loaded and then say, oh, I actually want to change something, you change something in the project and you want to recompile it and still have the IEX section, just call the recompile function. And the last one is probably the first change you're going to notice, especially if you have Git dependencies, is that we're now using HTTPS to fetch GitHub dependencies instead of Git, right? Because it's safer and it's going to be faster. So being a build tool, right, a lot of the improvements we expect is for things to be faster and make us more productive. And that's exactly what we have with Mix 1.1. So those are the good news, right? But we have some not so good news. We had some changes we had to do, some improvements to the language and we need, yeah, let's look at them. It's going to be easier to explain. So this syntax is deprecated, soft-deprecated. So every time I say soft-deprecated, I mean that we're not going to emit warnings. We just kind of like, in the documentation, we say, don't do that. In some places, we stop recommending it. And then we're going to deprecate eventually in future versions. So this syntax is soft-deprecated. And what happens is that before Elixir 1.0, we kind of like unified all of those sigils inside strings in the language, like \x. And \x is supposed to introduce a byte, the hexadecimal notation of a byte. And we end up accidentally supporting Unicode code points, but that's not how it's meant to be used. So that was self-deprecated. Here I'm using the Unicode code point for the white heart. And now we introduce the proper syntax for Unicode code points, so you should stop using the \x one. That's going to be only byte related in the future. So it's a small change, right? Something also that is changing with Elixir 1.1 is the whole idea of behaviors. And this was my bad, because we introduced the idea of behavior when Erlang 17 came out, because Erlang 17 changed how Erlang 16 worked, and then we introduced this abstraction so we did not have to worry about it. But before Elixir 1.0 came out, we were only support Erlang 17, which means the reason we need behavior was gone, and we forgot to remove it. We could have done that before. So now we need to do a longer cycle, right? So use behavior is deprecated, which means the docs are saying, don't use this. There is an easier way. And this code now is only going to be this, right? You just use the module attribute callback, and you define the things directly. And this is much better because def callback was something, it was an anomaly in the language, because it was the only place where you use the type spec notation with something that looks like functions, right? So now everything's using module attributes, and it's going to be much cleaner. And we also took the opportunity when we were working with the callbacks and the docs to unify how documentation is written in Elixir and how to access that. So I like to say that documentation in Elixir is first class, right? So now, so you can document types, you can document callbacks, as you can document functions, and you can document modules, and everything was unified behind a function called code.getDocs, which is great. For the people in the back, we have like a bunch of seats here. So if you want to come and stay close. Cool. So, and this was the only deprecation we had, and we had to do it, is that the access protocol is deprecated, okay? And I want to explain why it was deprecated and what changed. So the access protocol is the thing that we use every time we use the options bracket key syntax, okay? So every time so here you can think that I have a process, and that process is calling options bracket key. That's going to use the access protocol. And then we have some other process, and some other process, and some other process, because it's a very common and convenient syntax to use. So what would happen is that, and this is important, this matters only for development, okay? So what would happen is that in development, because you can still define the modules at any time, every time you use the access protocol, we would go through a process called the code server. James talked a little bit about it yesterday. And this becomes a bottleneck, right? Because you have all the processes want to reach one particular process. And we're actually seeing things being slow, because it affects only development and test. We were actually seeing slowdowns in development and test. Like your tests were getting slower because of this bottleneck. Especially we like to run a lot of our tests concurrently, right? So we had to fix that, and that's why we end up deprecating the access protocol. And what this means is that the access protocol is only the implementation mechanism that was deprecated. So this means that options brackets key syntax still works, okay? But what you can't do is that you can't like implement the access protocol or derive it. What is happening is that the access now defines a subset of the Dict behavior. So if you're using the access protocol for accessing dictionaries, keyword lists, and maps, it's fine. Okay, sorry, not the access protocol, the bracket syntax. And it's worth remembering that the bottleneck does not exist in prod, because if you create a new project, you can see in your mix.xs file 2 configuration flags called build embedded and start permanent, and those guarantee that your protocols are compiled and so on. And to guarantee that this issue is not happening in the future, we have inlined hot paths, right? So places where we think, oh, this can be called a lot with a map or with a keyword list, we inline those, and to make sure we're not doing pressure in the code server. Cool. So those are some of the improvements we have to the language, some of the deprecations. But the biggest changes that came with Elixir 1.1, they happened around, they were not code related. They are community related. And the first of those is the addition of a code of conduct to guarantee, and we are just following the steps of Hex. Hex was, I believe, the first to add a code of conduct. And Elixir Conference, we had a code of conduct since the first version. And now we are following along to guarantee that we continue providing a safe and welcoming environment to everyone. So thank you, Flavia, for the fantastic contribution. And yeah, someone wants to clap? Let's clap. Yeah. And we also now have certainly the most beautiful, readable, and clean documentation of all times, right? So this is the work for the XDoc team. We have now a great team working on the Elixir documentation. And this is how the Elixir documentation for Elixir 1.1 looks like. But you can use this in any of your projects, right? So if you get the latest XDoc and you generate the documentation for your project, that's what you have. And I know that the XDoc team is working on a bunch of new fantastic features. So here we can have an idea like the pages one on the menu on the left side is where you're going to put your user guides and tutorials with the documentation, right? So, and this is great because if you, in your tutorial, if you reference a module, now we can link to it in the documentation. So we are improving and improving this area. I know that the XDoc team is also working on EPUB support, so you can generate PDFs from documentation and so on. So a lot of very nice things happening here, and expect more and more improvements. Cool. So that was Elixir 1.1. And let's talk a little bit about Elixir 1.2. And then we can talk about what we are planning from long term. So for Elixir 1.2, we are not waiting a year, right? We're going to get to date soon. So, and the reason for that is because the main reason that we're going to release Elixir 1.2 is to be the migration to Erlang 18. So Elixir 1.0 and Elixir 1.1, we support both Erlang 17, Erlang 18, and whatever is coming next. But Elixir 1.2 is going to support Erlang 18 only and forward. And the reason for that is because there are a bunch of fantastic features in Erlang 18 that we want to leverage. Two of them, especially being, we will now be able to have variables in maps. So today, if you try to create a map, and the key is a variable, the compiler is going to say, hey, you can't do that, right? So you need to create an empty map and call mapput to put the value in there. So now that's going to work with Elixir 1.2. And so that's coming soon, right? And we have official support for large maps. And this is fantastic, OK? Because we are in a little bit of a messy place right now, which is, so the way dictionaries works in Elixir 1.1 is that we have three of them, right? We have keyword, we have map, and we have hashdict. And it's actually very confusing, OK, to know which one you need to use, especially if you are getting started. Right? So what would happen is that someone would write a script and say, hey, I have this script running in 5 seconds in Ruby, Python, Go, or something like that. But the Elixir one is taking a minute, right? And then you would look at the script and say, oh, it's because you're using a map. If you change the map to hashdict, things are going to be fast. And then they change it, and they're like, oh, it's as fast as everything else, or even faster, right? Because it's very confusing, right? And it's completely our fault. And to make things kind of, and to make things better and worse at the same time is that, yeah, that happens, is that we unified all of the APIs through Dict, which allows you to easily change one for another. But it's yet another thing you need to understand. Right now you have like, oh, I have 4 ways of working with key-value data structures. OK? So too many options, often confusing. And now that we have large maps, which means, and by large maps I mean, so today in Elixir, maps, they're useful only for a couple dozen keys, OK? And if you put a lot of, it's linear, so if you start putting like 1,000 keys, things are going to get really, really slow. So with large maps in Erlang, what it means is that Elixir 1.2 is going to have keyword lists, which is what we usually use as options, and they allow duplicated keys, they're user-ordered, OK? So they have a very specific use case, which is just, you want to pass options around and you want to keep the ordering. That's what we're going to use. And maps. And maps, they provide pattern matching. As we know, it's the maps that we have today in the language. It's just that now they are scalable. Okay? Scalable in the sense that you can put 1 key, you can put 1 million keys, and they're going to be fast. And the difference is that maps, they have their own ordering. We don't have control over the map ordering, different to keyword lists. So now we have 2 options, very clear, straightforward options. They don't really clash with each other. You use one or the other. So what we can expect for in Elixir 1.2 is that, and this is Elixir 1.2, OK? Hold your horses. We are on Elixir 1.1. So hashdict will be soft-deprecated. In Elixir 1.2, hashdict will be soft-deprecated. You can just use map. Hashset will be soft-deprecated. Just use mapset. And mapset is a new data type that we have, which is a map, which is a set implemented on top of a map, and it's faster than hashset. And the dict and set, they will be soft-deprecated. And reminding that soft-deprecated means we are going to say in the documentation, hey, stop using these, and eventually, at some point, we are going to deprecate it. Okay, so those are some important things that it's happening with Elixir because we can use the latest Erlang, and that's great. But we also have a couple features of our own. For example, now we have multi-aliases. Who wrote a code that looks somewhat like this, right? Now you can just say this, right? You just say, hey, I want to alias my app, and I want to alias foo, bar, and bass, right? It's very convenient, and it works with imports, requires, use. And as I said, we really don't want to wait a lot. I hope we can get the new Elixir 1.2 out still this year, okay? Because It's just a matter of updating and streamlining things and make things faster. Meanwhile, upgrade to Erlang 18 plus. Go to the latest Erlang. And it's really worth it because we have worked with the OTP team to make compilation altogether faster, both for Elixir and Erlang source code. And it really shows up. So when I'm compiling my code, I can see like 10 to 20% improvement across the board for everything, compiling code, running tests. So it's really worth it. And you know, it's important to say that compilation in Elixir is not slow, right? We compile things reasonably fast, but we are still working on making things even faster in Elixir 1.1 and now in Elixir 1.2 because, you know, if we save everyone like 30 seconds per day, right, it multiplies really, really fast. So that's cool. Cool, so that's the short-term version. And now it's the part that I can go crazy and make things and say things that may appear next year or may never appear. So it's my favorite part. Yeah, so I cannot be held responsible for anything from now on. So, and this is a common theme, OK? So if you were here last year or if you watched my talks at ElixirConf Europe, I'm always talking about collections, right? Like collections, 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 collections. And so let's look at this example. So here I have widgets, which can be actually anything, right? It's a collection. We don't care really what is the data type. And we are mapping to get only the widgets that has, why I name it the variable b? Yeah, sorry. So, so we have widgets, and then we are filtering them to get the ones only with the color red. And what Enum filter is going to do is that it's going to traverse our whole data type, right? So it gets the widgets, it traverses the whole thing, keeping only the one that has, only the ones that have color red. And then we go and we map on the whole. Now we have the whole collection, new collection filtered, and then we map, converting everything into a tuple with the widget title and the height, and then we put everything into a map, okay? And we say that the widget here, it's a source, and for us, it implements the enumerable protocol. So anything that implements the enumerable protocol, we can put there, okay? And the map here is a sync, is anything that implements the collectible protocol. And what the protocol also does is that if we want, we can have this code, and then we can just replace it by this code, where now our source is like something that's going to parse the widgets out of a CSV file and is going, and at the end, the into, it can be some I/O device. So every time you have a widget, you just print it into the terminal, okay? But the issue with this is that each step traverses the whole collection. Everything is eager, right? So we have CSV parse. And then what we do is that when we parse and we load everything into the memory, and then we filter, and we have a whole new collection in the memory, and then we map, and then we write to the I/O device, which means that imagine I have a really big CSV file. What would happen is that you would run this code, and then you would wait a while, and then everything will be dumped at the terminal at once, okay? So what we can do is that we have collections, and what we have, and this already, we have that in Elixir, right? And what we also have in Elixir is that we say, oh, OK, so maybe I don't want to traverse everything in one step. I want to make this lazy. So what we do for that in Elixir is that we replace the enum module by stream, and then we have laziness. And the way laziness works is that now I'm going to get the first entry of the CSV file, OK? And then I'm going to say, hey, am I keeping this entry or not? And then if I'm keeping it, I'm going to map, and then I write to the terminal, right? I write to the I/O device. So we have like, now the data is kind of flowing through those steps, and you're going to see things being printed to our terminal as they are being processed, as they are being parsed and mapped, and so on. And the reason for that is because stream, when you're calling stream filter, stream map, stream into, we are not really performing the computation at that moment. We are just storing those computations, right? So we store, and then when you call stream.run, we put all the computations together and run the collection through it, okay? And that's really, really great, right? It's very handful in a bunch of interesting situations because now it's the streaming. We can even work with infinite collections. And that's what we do when we have something like gen event stream. We are consuming events that can last potentially forever, right, that are coming forever. But after we got to this point, and this is where we are right now in Elixir, and that's the question I believe we made even last year was, if I'm storing the computations, right? So we stream stores the computation, we don't perform it. We could actually get this computation, say, hey, I want to run part of this computation in one process, right? In one Elixir process, and the other part of the computation in this other Elixir process, right? And have the data flowing through them. And that's what we call pipeline parallelism. So we could maybe have pipeline parallelism, OK? And how this would work is that here I added just a simple call. So right after CSV parse, what if we call stream async? And what stream async is going to do is that it's going to happen, hey, everything that is above here, everything up to this point, I'm going to run that into a separate process. And this separate process is going to do whatever it has to do and send it to the current process. So if we do that, and then if we add a bunch of stream.async calls, you could think that we have something like this, right? We have the CSV process, right? And then the CSV process is start parsing, and then it sends the data to some other process that changes a little bit and sends it to another process that sends it to another process until it's the place where it's done, or you are collecting everything into a map, for example. OK? And the thing about pipeline parallelism, OK, is that if we're now calling async and if you're calling stream async, stream async, stream async, we're saying that each of those stages, they are now a process. And every time we put things into processes, we need to think about this question. What happens if one of those processes crash? Am I going to abort the whole pipeline? Am I going to abort maybe only upstream, maybe only downstream? And also, we need to answer how to provide back pressure. Because if we have a process in the middle, right, that is slow, that cannot process the data, we cannot continue to push data to it, right? We need to provide back pressure, say, hey, slow down, I cannot consume things that fast. And the question is, so another way to phrase those 3 bullets is, how can we make streams supervised processes, right? Because now we're saying, hey, I'm doing stream async, and each step is creating a new process, right? So how can I go from this stream that we had when we call stream filter, stream map, to supervised processes so we can react to failures and we can provide back pressure? Because the process, they're able to provide back pressure, right? They have state. They have state. And the truth is, pipeline parallelism isn't even a good strategy, right? Because we are sending the data around. Sending the data around is expensive, right? And we know that every time we send a message from one process to the other, there is copying. Okay, so it's not even a good strategy, but it's a very simple strategy. Okay, and we were looking at it for a while and say, okay, so we know that pipeline parallelism isn't a good strategy, but we know it's simple. It's a good starting point to think about. So we were looking at this question: how to make streams, how to go from that stream thing, the stream data structure, to supervised processes. And we were wondering it for a good while, and we were stuck. Okay, so that's probably why you're listening me talk to it about 1 year, because we were stuck. Okay, but we made good progress lately, and that's because we slightly changed the question. Instead of asking how to make stream supervised processes, we asked how to make supervised processes stream data. It's a small change, right? But it's a perspective change. Instead of starting with streams and make them processes, what if we get the processes, make them stream data, and then at some point later on, we're going to see how that maps to the streams, okay? And the answer that we got for this question is something that we're calling the GenRouter, okay? So the GenRouter is going to be a new behavior, as we have GenServer and Supervisor. And the idea of the GenRouter is that it connects source to sinks. And GenRouter, they are demand-driven. And that's what we're going to talk about for the rest of the talk, just to give an idea of how the GenRouter, we expect it to work. So here's a GenRouter, right? We have a process. It's just a process, right? And then it's receiving data from sources here on the left side. And it's sending this data to a bunch of sinks, okay, which are a bunch of other processes. Okay, so now we left the data structure that we were thinking before. Now we are thinking only in terms of processes and data flowing through those processes. And it's important to consider that this is a topology, right? So the GenRouter is also a sink to its sources, right? So those sources are sending data, and for their perspective, the GenRouter is the sink. And at the same time, the GenRouter is a source because it's sending data to a bunch of other processes. And for those other processes, when they look at the GenRouter, they don't care. They say, oh, that's my source, okay? Which means that we split the GenRouter because we need to handle the sinks and we need to handle the sources. We are splitting the GenRouter in two things, the in part that's handling the incoming events and the out part that are handling the outgoing events. So how you would start a GenRouter? You would give it the implementation of those two parts. So I'm going to say GenRouter start link. I'm going to give the implementation of the in part, maybe some arguments I want to give for the in part, and then the out part, the implementation of the out part, and the arguments I want to give. For example, I could have this, okay? So here I'm starting a GenRouter, and let me say, hey, this GenRouter is going to have a single source because those are the easiest one to manage. And I'm going to have a BroadcastOut to handle the out part, which means I can potentially have a bunch of sinks, and every event I receive, it's going to be broadcasted to all the sinks, okay? So this is how it could look like. So if I have a single in BroadcastOut GenRouter, I can have one event coming, and when this event arrives, I'm going to broadcast it to all the sinks. And then another event arrives, and I broadcast it to all the sinks, and so on, right? But as I said, now those parts, right, they are the same way you implement a callback to have your own Gen server. You can implement a callback to customize how the GenRouter works. So you can replace the single in part by a dynamic in part where you can receive data, okay, from any other process in your system. So where this would be useful, for example, if we are get a Phoenix application, you can have a request, and and all the different requests coming to your system, they can potentially put something into this into this topology, right? So they would go to the GenRouter and say, hey, here's an event that's happening, and then the GenRouter takes care of sending it to the REST, and that REST is going to start processing it and digesting it in whatever way it wants, okay? And so this is very similar to the Gen event, if we think about it, right? It's just, hey, I'm sending an event, and then it's broadcasting it to everyone that's interested in it. So that's an interesting topology, right? And that's an interesting pattern that we can do with GenRouter. But we can do a bunch of other interesting stuff. For example, so previously we had the single in, and I replaced by dynamic in. So what if we have a dynamic in and a message queue out? And the message queue out is a GenRouter that is going to send the event to the process with the shortest message queue, so which is going to be the process that is more likely to process it in time, okay? So what's going to happen is that this is kind of a worker thing, right? I have an event, I send it to the GenRouter, and the GenRouter say, hey, who is the one that is less busy? Oh, it's you, so I'm going to send it to that process. So now we have the first event coming, right? That is going to the first, and then the second to the second, and then the third to the third, and then the next time, depending who was the fastest process, is the one that's going to receive the next one, and so on. Okay, so with the GenRouter, we can express all those different and interesting patterns. So from this very quick description, right, we saw some very interesting and useful cases, right? So we saw that it can be used as a Gen event replacement that is process-based. So Gen event has a couple different issues. And the biggest issue, my biggest issue with Gen event is that when you create a Gen event and you install handlers on it, those handlers, they're all in the same process, the Gen event. They're not concurrent, right? So they're not really isolated to it. It's a weird thing. So now we have an actual Gen event where all the things that are receiving the events, they're other processes. So we have concurrency, we have isolation, okay? We also saw a way to load balance jobs across a pool of processes, right? So it was the dynamic in message queue out. You can have, again, if you think about Phoenix, for example, you have the web requests. They are putting something to the GenRouter, say, hey, send an email, and it's a pool, and it's going to send to the process that can send that email the fastest. Cool. So that's what you can do with the GenRouter, right? And so that's what the first thing I said. So the GenRouter connects source to sinks, okay? But the other thing was that GenRouters are demand-driven. And that's possibly the most interesting aspect and important aspect of GenRouters. So what do we mean by being demand-driven? Okay, so Remember when I said that the pipeline parallelism is not really useful in practice, but it's good to think and reason about things? So here it is. We have, again, that pipeline parallelism, OK? And let's use it as an example to think how the demand-driven aspect works. So here we have like those processes, right? And they are sending data one to the other. And we can say that A, as we said before, right? So A is a source to B because A is sending events to B, and therefore B is a sink to A. And the same way, B is a source to C, and C is a sink to B. Okay? And this being demand-driven means the following. It means that when we connect those processes, A is not going to start sending data immediately. What is going to happen first is that C is going to ask for data. So C is going to go to its source and say, hey, I can handle 10 items, right? And then B, oh, OK, so if I'm a router, I'm going to just signal this demand upstream. And B is going to say, hey, I can handle 10 items. And now A knows, oh, I can start, A is the source, right? It's the definite source. Oh, so I can start sending the data downstream, right? And then it's going to send data to B. And it's going to send and it can send one event. It can send 5 at a time. It can send 10 at a time. But it's not going to send more than 10 altogether. It cannot send more than it was asked for, OK? So A is going to send events to B, maybe 2, 2, 2, and 2. And then B may do those things, and eventually it's going to give those things to C. Okay? So being demand-driven is very important because when we do that, we are pushing the back pressure to the system boundaries, to the source, which is exactly where we want it to be. So imagine that A is something that is receiving data from a logging system or from RabbitMQ, from a queue system, right? You don't want RabbitMQ to flood your system, right? You actually, if you have this whole processing pipeline, right, what you want is that the thing at the bottom says, hey, that's how much I can handle, and that demand is going to go upstream to the boundary, to the source, so we know how many items we want to get from the log system, from RabbitMQ, and so on. So this is very important, right? And the demand-driven is actually very simple. It's only a message contract between processes. It's just a way that processes say, hey, I'm going to send you ask messages. And when I send you ask messages, you can send me events in this particular format, and I know how to handle them. And it's very important because it pushes back pressure to the boundaries of the system. Okay? We are sure that we're not going to have events coming to the system, and then the system starts to grow more and more in memory, and then it gets slow because it needs to start swapping memory, and then the whole thing dies, and we are very sad. Okay? So the back pressure is extremely important, right? And the GenRouter is just one implementation of this contract. And I have to think, so this demand-driven aspect, which is kind of the very interesting thing here, it's not new. It was heavily inspired by Akka streams. So Akka, they are doing that in the way it's relatively new in Akka also. I think the Akka streams version came out just a couple months ago. And it was, again, the whole idea of having the back pressure, right, and control this demand. And I have some folks in the Akka streams team that they have been very helpful in answering my questions and providing guidance. Okay? So that's it, right? So we have GenRouters, right? And we can build those topologies now. And we know that it's going to be demand-driven, which means we can signal the back pressure to the boundaries of this whole topology. So, and we showed a couple examples, right, of what we can build with GenRouters. Like, hey, we can replace gen events. I can do like kind of a job balancing thing. But here's another cool example based on the demand-driven aspect. Now, imagine that you have, what you want to do is that you want to do a TCP acceptor. You want to accept TCP connections, and you want them to be supervised. So you should be able to do something like this. You can create a source now, which is the TCP acceptor. The TCP acceptor is the boundary of my system, right? Is the thing that is going to be receiving the connections. So that's my source, OK? And what I can do is that I can create a sink, which is a GenRouter supervisor. And the GenRouter supervisor, are going to give it some parameters like, hey, this supervisor can handle 10,000 of processes. Since it's TCP connections, we know that the Erlang virtual machine is going to be fine with 100,000 of processes. So they say, hey, I can handle 100,000 connections. And because now they speak the same demand-driven message contract, I can just say, hey, I have a, so those things, they are GenRouters, right, in the sense that they are the source and the sink. So I want to say, hey, I want the supervisor to subscribe to the TCP acceptor. They are just processes. And when we do that, we're basically saying, I want the supervisor to ask the TCP acceptor for events, right, which are socket connections. And when the supervisor asks for data, the TCP knows, oh, now I can start accepting things because there's demand coming from the string. And that's it, right? It's 3 lines of code, and you have like a supervisor TCP acceptor, and you could put that in your supervision tree and be happy. And that's just the beginning of the things we can express and build with those constructs. Okay? So the path forward here is to define a demand-driven message contract, and it's mostly defined at this point. But we need to build more and more things to guarantee that this message contract is exactly what we want. And that's exactly where we are right now, okay? We are implementing GenRouter, and some of the conveniences are showed here, and we are going to start stressing them out really, really soon. And after we do all that, then we go back to our initial question, which is how can we integrate all those things with strings? Because the string things that we know and love today, they are very useful to express the computations, right? So how we can get now those two things and put it back together. And that's it. That's what I had to share about the things that we are experimenting with and working on for Elixir 1.3. Maybe it's not even going to be in Elixir 1.3. Maybe we're going to release it as a separate project so everyone can use in Anger and try it out in production. And when we think it's stable enough, we include it into Elixir, right, and continue building on it. So those are the things I wanted to share. Thank you very much for listening. And I want once again to thank my company, Platform Attack, for investing in Elixir and in the ecosystem throughout all these years. That's it, and thank you very much.